talk a little about building a small alternator with 4-inch diameter steel discs. These are 4-inch diameter, 1/8 inch thick. Drilled them out 3/8 of an inch in the center. It's all going to run on a 3/8 inch shaft. I'll just be testing one coil today, but kind of show you how it goes together. The magnet rotors will look like this. I've just got this one on a bolt for testing. So 4 magnets. Each magnet is 1 inch diameter, 1/4 inch thick. These are N42 grade neodymium iron boron magnets. The way I made the magnet disc, this is all 3D printed stuff. This part just goes around the outside. Kind of looks neat and helps center everything. That goes in the middle. And these magnets are strong, but these little guys aren't too bad. They're safe, fairly safe. They just fit in here. You want alternating poles going around, so in this case I can just feel this magnet. That's repelling, so I know if that's a north pole. So is this a north pole? Meaning that's a south pole. So I don't turn this one around, I'll just put it there like that. So basically the bottom of every magnet should repel its neighbor. That one attracts, so I gotta flip it over. That guy repels, that repels. So it's good to go. Gotta keep these guys separated. So that's done. The only thing I'll do on this for testing, this is still loose in the middle. We could take this out and just glue the magnets in there, but I'm just going to tack this down with a little bit of cyanoacrylate glue, otherwise known as super glue. And this glue here, it comes in different viscosities. This is medium viscosity. I'm just going to put a little dab on each edge so I can take it apart later if I want to. And this is activator that when you spray it on there, it'll activate these cyanoacrylate glues real quick. So this, you can actually see it getting hard already. I'm going to put this away for safety way over here. If these two got stuck together, it could be dangerous, so they need to be kept apart. Next step will be winding a test coil. If I build a whole stator for this, I want the diameter of the coils to be 2 inches, and that way 4 coils fit nicely around the 4-inch disc. I should have mentioned, this is a single phase alternator. Normally I build 3-phase, but for simplicity, we're just building single phase. So this fits up real nice. 2-inch diameter coil, 1-inch diameter magnet. These leave a little room at the middle for a shaft and stuff. And they almost touch each other, which is good. And they come right out to 5-inch diameter from here to here. Is exactly 5 inches. So this, if I load it up with coils, would be a full stator, but I'm not fixing to do that. I'm just going to make one coil like this so I can test it. The stator I've come up with and the test coil, these are actually they're exactly 5/16 inch thick. You don't want to get the coil too thick, or the flux through the coil gets weak. So there's a compromise here with the air core alternator. You want to keep the coil thin, but you want some copper in there. And I believe that in this case, 5/16 is kind of the sweet spot. This is the coil winder. These will be the centers of the coils. In these coils, the center will stay with the coil. So I've printed up a whole bunch of centers because these will become part of the coil. This all goes together on a bolt. Let's see if we've got one this. I'm winding with 24 gauge wire. So at this point I'm going to run a piece of wire through here. Nice length here for testing. And I'll wind this in the drill. I already got one wrap on there by accident. So this is 24 gauge wire. I've already done this once. I know that about 250 turns will fit this about perfectly, but I'll count them anyhow. Actually, I've made a few of these and I know 250 turns fits, and the goal is actually, once I know how many fits the space, I load it up. So you don't have to take all day to wind a coil. I can do like this. You can go fast once you know how many turns you've got. Okay, now the coil's wound. This is all filled up. I might have forgot to mention, these discs are exactly 2 inches, so once this is filled up, I know it's full. And I know it's going to be right around 250 turns. This is all still kind of tight, and before it comes loose, I very carefully put a little bit of the super glue down the edge to hold that outer winding on, and then hit it with the activator. I'm going to do that a couple of times just because I want this coil to stay together neat. If I don't do that and take it off, it's going to be tricky to hold this outer winding on, and it'll become kind of messy. So now this is kind of strong. Don't have wire clippers, but scissors will do. Now I can take this apart. This isn't hard, but winding the coil is probably one of the trickier parts. The way I'm doing this now is putting down a piece of wax paper in the corner of the table, and this is going to be for my test coil. This process is the same if I was doing the whole stator, but I'm just doing a test coil because from this test coil I can predict exactly what will happen in here. That there. Get my pocket knife, I might need it. Straighten this end because it's poked through the hole. I'm going to poke the whole bolt out and keep all this together. Take the bottom off. In theory, I should be able to poke this whole thing in here now. So I'm going to take some glue, put it all around here, put some around the edge here, some in the middle, and poke this whole thing in there. It's pretty good. Get a bit of stray windings there. Fold this over. And what I've done before is cut a little piece of paper. One of the most fragile, this is actually just a napkin, but it'll work fine. One of the fragile spots on these coils that likes to come undone is where this wire crosses over the top. If I put some glue down on that, and actually glue down around everywhere, just put this little piece of paper on there. That'll kind of hold that wire down. Fold this over. Smash it down good. And let that sit for a while. I might let that sit for 20 minutes, half an hour. And then when I take it out, if I only wait 20 minutes or half an hour, that glue may not be perfectly set up yet, but it'll be set up enough to hold the coil together. And then I'll spray it with this stuff. That'll set it up real fast. The end product will look like this. And you can see how hard I smashed this one. You can see the indent of the wires in there. But yeah, it comes out nice and it's very strong. So now I'll test it over here. Okay, I'll set it up in the milling machine here. Testing coils and magnets. One thing that's really important in any alternator is the distance from the magnet to the coil. There's a dramatic difference if you run a sloppy air gap or if things are wobbling. So it's worth taking some care to get this set up well. So I'm just running one magnet rotor on here. And this is nice and flat, so I can put this in the mill, or in the vise like this. If I was running magnets on both sides of the coil, I would get exactly double the result. Whatever I show here, I'm going to get double that with two magnet rotors. I could also put a blank steel disc on the back side, and that will also increase output. It could be as dramatic as 50% if we run a nice tight air gap, but that depends on the air gap quite a bit. So what I can do is bring this over. Kind of eyeball. We can actually move this in and out and look at voltage and find the sweet spot. But yeah, I can test it right now. I'll bring it in close, I guess, for now. That's about 1/16 of an inch. Start the three-phase converter. I've got the machine set right at 500 RPM. And at the 500 RPM, this is actually quite accurate, so. So to run like that, and I'm just looking at AC voltage. I want to know how much voltage AC do I get off this coil. 150 turns of 24 gauge wire. So in this case, got about 1.6, or I'm sorry, 1.8. I can play a little here. That dropped off. It's playing with the table position. So about 1.87. So that's very telling. If I want to add another rotor, I can double that. If I want to wind with 27 gauge wire instead of 24, I could fit 500 turns and double it again. So this little bit of data tells me everything I need to know about these magnets and this magnet rotor and a coil of this exact dimensions. It's also worth noting on this that the resistance of this coil is about exactly 2 ohms. So if we're doing power curve, if we're trying to guess the power curve of a completed alternator, that's important to know. Anyhow, that's all.